Good afternoon to all. In the previous video, we have seen about shielded metal welding, or otherwise known as SMAW. So here, as I already said, we have seen about filler metal, that is electrode, and it is coated with the flux. So the flux in turn forms the slag. So here, as the slag, as I already said, is a combination of flux coating and impurities. It is coated on the it will be floating when it is when the filler metal is in the or the filler electrode is in the liquid state while welding. After that, it becomes solid. It is coated. And looks like it is coating on this surface. So after the slag quickly solidifies and form a solid coating, the slag is removed with the help of wire brush. The main important thing is to remove the slag is that the slag slows the cooling rate of the weld, and it also it's a homogeneous material, right? It's impurity, so it acts as a starting point of a crack. So the main thing, okay, when we come to the SMAW, that is shielded metal arc welding, when it comes to the advantages part, equipment is less complex, because it's a very basic type of welding. So when we look on the other types of welding, this SMAW is less complex and it is portable and less costly, because once you have a 3-phase current, and if you have a portable transformer, it can be taken to anywhere, and it can be welded, and it can be used for welding of materials, mainly metals. Okay. It can be used in indoor or even outdoor, in any location or in any position. Okay, the electrodes available to match properties and strength of most base metals, but it is some cons is that it is not used for welding soft metals, and it is not as efficient in deposition. Means that here the deposition point of view, the efficiency of this process is less when compared to the other welding process, as the deposition rate is uneven, and it cannot be used for softer metals because it puts holes while the welding happens. And the main application point of view, this SMAW process is often used to weld carbon steel, low and high alloy steel. Comes to carbon steel, it is maybe can be used for high carbon, low carbon, and even medium carbon steels, and it is used for low and high alloy steel, and it is used for stainless steel, cast iron, and even in ductile iron. So while it is less popular for non-ferrous metals, it can be used on nickel and copper alloys, nickel, pure copper and their alloys, and in some rare cases it is used on aluminum as well. So this SMAW process is sometimes used as in the hybrid mode. Means that if a welding okay, for example, if a workpiece which is made with a V groove has a thickness about, the metal thickness, the welding plate thickness is about 6 mm or some 6 mm to 7 mm. Eventually we have some root, and we have a shape like this. We have some root here pass, and we have a shape like this. So for the root pass, they will use TIG welding process, which, because the deposition rate is very minimum, it can be used to cover the root area, which, because it fills the it will cover the or fill the root with up to a thickness of 1 mm alone. Okay, for the rest, if it is 6 mm, for 1 mm we will use TIG welding at the root pass, and if it is sufficient, if it is not sufficient, we will use another first pass with this TIG welding process. So out of 6, 2 mm is taken away, it is filled away. Now the rest of the 4 mm is filled with this SMAW process. So with the same composition of the filler metal which is used in this TIG welding. So moreover, this SMAW process, as I already said, it can be used as the in hybrid mode with as par with the TIG welding. Moreover, the thing is that this SMAW process is very easier. We don't need any skilled laborers to perform this operation, perform this welding, right? And moreover, this SMAW process, as I already said, can be used for any any metal, more preferably ferrous materials, so that here for coating type of welding or some structural types for keeping a tag type welding, this SMAW is mostly preferred. Thank you.